A simple pendulum consists of a mass M hanging from a string of length L and fixed at a pivot point P. When displaced to an initial angle and released, the pendulum will swing back and forth with periodic motion. Build a pendulum setup as per the YouTube video from Harvard, then create a worksheet or computer program to provide information about period, frequency, angular frequency, position, and damping constant per pendulum. We try to produce as many graphs of position versus time as possible. First, we built the pendula setup using recycled material, the base and frame wood. We didn't follow the exact design as the Harvard video, because making the V's was a little more complicated than we expected. At the top, we drilled 16 holes for the 15 pendulums. Then we measured each needed length for each pendulum and hung them. And we created our program to calculate the system's damping constant and each pendulum's length, period, frequency, and angular frequency. We used HTML and JavaScript for this matter, and the program's algorithm is simple. The user just has to enter the length of the longest pendulum of the system, the overall cycle length in seconds, and the selected pendulum of the system to calculate the variables. Third, and finally, we generated the graphs for each pendulum.
Our pendula setup was made with a 60 by 30 centimeters wood base, a frame of 50 centimeters in height, string, and 15 3/4 minus 10 knots of 50 grams in weight.
We created our program using the following formulas. We use a GeoGebra grapher to produce the graphs of every pendulum.
The pendulum setup will cycle through many patterns over our chosen interval, which was 30 seconds. First, the waves, then the pendulums in sync by pairs, and even chaotic motion. Our main recommendation in doing this project is to measure correctly the length of every pendulum. Also, use weights that are easy to tie to the strings, and the heavier they are, the better the system will work.
In conclusion, this is a great project to understand the oscillations of a pendulum, but as it has to be extremely exact to work properly, it isn't the easiest project.